Hi everyone. So in this video, we will work through a mechanics question from the Year 12 AS 2018 paper. And this question is about motion graphs. So a train travels along a straight horizontal track between two stations A and B. In a model of the motion, the train starts from rest at A and moves with a constant acceleration of 0.3 for 80 seconds. The train then moves at a constant velocity before it moves with a constant deceleration of 0.5 meters per second squared, coming to rest at point B or location B. For part A of the question, for this model of the motion of the train from A to B, state the value of the constant velocity of the train. But just before we get into the video, I want to make you all aware about a web app that I have created. Now, this app that you see on the screen here is designed to predict the 2027 Edexcel A-level Maths topics that will come up in your 2027 exams. So now that the 2026 exams have finished, we now have access to those questions. So what I've done is I've analysed all of the questions from 2026 back to 2018 and also including the sample and the specimen Edexcel papers. And I've used that data to put together a model which will predict the topics for the 2027 exams. And if we just scroll down here, you will see how accurate this model that I'm using is. So if you do want to have access to the full predictions for the 2027 exams and also have access to a web app which will generate mock exam papers based on these predictions, that is what you can get if you do sign up to this app. Just go to the link in the description of this video, and also you can get the link to this web app in my bio. Click that link, sign up. You can see on the top right of the page here, you can sign up. Sign up to the app and you'll be able to access all of these 2027 predictions. Okay, so in this part A, part I, we know the acceleration is 0.5. It's a constant acceleration. So if the acceleration is constant, so acceleration equals constant, that means you can use SUVAT. Okay, so anytime when acceleration is constant, just use SUVAT. So let's write down our letters S, U, V, A, and T. So the distance traveled in this first stage of the journey when we're accelerating 0.3 meters per second squared for 80 seconds, we don't know, but obviously we know the acceleration is 0.3. We know the time is 80 seconds, and we know that the train is starting from rest. So the initial speed is 0. So which equation can we use? We want to find V, of course, that's what we're looking for. We can forget S. So we're going to use V equals U plus AT. So V is equal to 0 plus 0.3 times by 80. And if we do 80 times 0.3 on the calculator, that is going to give us 24. So 24 meters per second would be our constant speed. So we accelerate for 80 seconds and then we reach this constant velocity of 24, and then we come to a deceleration. So part II of part A says state the time for which the train is decelerating. So in this instance, again, the train is decelerating at a deceleration of 0.5. So in other words, an acceleration of negative 0.5. We start with an initial speed of 24 and we finish when we come to rest. So a speed of 0 or a velocity of 0. So again, we'll use SUVAT because this deceleration is constant. So it's a constant acceleration. So use SUVAT again. So we have distance, we have initial speed, which in this case is 24 now. We have the final velocity of 0 because we're coming to rest at the end of the journey at point B. We have the deceleration or the acceleration of minus 0.5, so acceleration minus 0.5 in this case because it's decelerating. And we want the time, that's what we're looking for. So which equation can we use again? We can forget the S. We can use exactly the same equation once again. So use V equals U plus AT. So 0 is equal to 24, and then A minus 0.5 times T, so 0.5 T there. So 0.5 T is 24. So then times both sides by 2, we get an answer of 48 seconds for part II. Now then, for part II, sketch a velocity time graph. So now we've got all the information we need now to really sketch this velocity time graph. Let's do this down here. So we're going to have velocity on the y-axis. Let me just rub this out and do this a little bit neater. There we go. So velocity will be up there. Velocity meters per second. We'll have time over here, time in seconds. So remember, we're accelerating at an acceleration of 0.3 meters per second squared for 80 seconds. So let's just put like 80 here. And we're going to be accelerating, constant acceleration like that. So it'll be a straight line graph like that. This will be our speed of 24 that we worked out. And then we will be traveling along for a little bit. And then there will be a deceleration. Now, the steepness of this deceleration at the end is going to be a little bit bigger or have a bigger magnitude than the steepness of the initial acceleration, because this deceleration at the end is 0.5. That's a bigger magnitude than the initial acceleration. So this line at the end just has to be a little bit steeper, like so. Now, we're not told in the question how long the train is moving at this constant velocity. So we don't know that information like to work out this time there. But we know that this time period there is going to be 48 seconds. So we can just label that there, just so we know the time there. Perfect. So that's part A done. Just another quick interjection. If you are currently doing Edexcel A-level Maths and you feel that you're struggling or you're falling behind and you're not quite getting that grade that you need to get in order to get into university, or perhaps you're a parent watching this and you're worried about your child's progress, what you can do is you can head to my website. Now, my website is in my bio and also in the description of this video. Click onto the link and you can watch a brief video about me and my background. You see this video on the screen here. In this video, I outline the style and the structure of my tuition. You can also read some of my reviews and testimonials from other parents and students who have worked with me on this website too. So if you feel like one-to-one tuition is something that would benefit you in order to get the grades that you need to get, then again, just head to this website. And what you can do is you can book a free 90-minute call with me. And in that call, we'll spend some time discussing you, your situation, your ambitions, what you want to achieve, the grade you want to get, and why you feel like you're struggling and why you feel like maybe tuition is the right path for you. And we'll also spend some time basically doing a free trial lesson where I will help you out for free with any particular topics or any particular areas of the syllabus that you know you need help with. And by the end of the call, we can then discuss whether one-to-one tuition is the right path for you to get you that grade you need to get. So once again, the link to my website is in the bio and in the description of this video. Now for part B of the question, so the total distance between the two stations is 4,800 meters. Using the model, find the time taken by the train to travel from A to B. Now remember, the distance traveled with a velocity time graph is your area under the curve. Okay, so the area under a velocity time graph represents your displacement. So what we're going to have to do with this part is we're going to have to work out the area of this shape here. And then by working out the area of the shape or getting a formula, we can then set that equal to the distance traveled of 4,800. So let's do this here then. So let's just say that 4,800 equals area under graph. So what we're going to have to do is just try and work out the area under this graph here. So this is obviously a trapezium. Hopefully you can see that's a trapezium there. So what we're going to need to do is we're going to need to work out or write down the formula. So we need to know this length there, which at this moment, we don't know what that length is. We're going to need the length on the bottom. Don't know that as well, that bottom length from A to B. But we know the height is 24. So let's just say that this is a half of A plus B times the height of 24, because remember, that's the area for a trapezium. So this is, in other words, going to be 12 times A plus B. And if we just label that that's A there, and then this kind of distance, if I could fit this in there, that would be the distance of B. Now, what I'm going to do is I'm going to call this time here time D, the time when we start decelerating. So let's do that. Let's call that time for deceleration. So that means that the base of this trapezium is going to be the time that we take in order for us to start decelerating plus 48. So let's write that down here then. So 12 and then multiplied by time of deceleration plus the 48. And then we need to add on this A. So that A is the gap between the time of deceleration and 80. So in other words, TD minus 80 would be that height on the top there. So TD plus 48 and then plus the TD minus 80 for that gap that we are looking for. Perfect. So now then what we can do is just simplify this. So 12, and then we have here 2TD, and then 48 minus 80 is going to give us minus 32 there. Now what I will just do, I'll just divide both sides by 12. So 4,800 divided by 12, that gives us 400. So 400 is equal to 2 TD minus 32, add the 32 to the other side, and then we can divide by 2. That will be the time that we take in order for us to start decelerating. So 432 divided by 2, this gives us 216 seconds, 216. So this TD there is 216 seconds. The question was to find the total time of the journey to travel from A to B. So we just need to do TD plus the 48 there. And then we've got our total time of journey. So total time must be 216 plus 48. And if we do this on the calculator, plus 48, this gives us 264 seconds. And that is our answer there for part B. Perfect. Now let's go to the final part, which is part C. So suggest one improvement that could make the model more realistic of the motion of the train from A to B. Okay, so if we go to our speed time graph or our velocity time graph, let's just rub out this big circle there, if it will let me do so. There we go. Now, what you'll notice is that, again, we're accelerating for 80 seconds, and then our acceleration instantaneously becomes 0, because at this point here, we now move at a constant speed. So in other words, the acceleration here is now 0. So in reality, are you going to jump from an acceleration of 0.3 to an acceleration of 0? In reality, no. There should really be a smooth transition from your acceleration of 0.3 to an acceleration of 0. And the same here is as well, likewise over here. So from this constant speed or this acceleration of 0, there should really be a smooth transition to this negative 0.5 acceleration. So I'm going to mention that as an improvement to the model. So I'm going to say here, in reality, there would not be an instantaneous jump in the accelerations from 0.3 to 0 and 0 to negative 0.5. So I'm going to say account for a smooth change in acceleration instead. So really, in reality, you would expect this curve that we've drawn, sorry, I've not spelled acceleration correctly there, acceleration, you would expect the curve that we've drawn to be a smooth curve, really, at these two transition points, rather than a solid jolt of acceleration or a solid jolt of the gradient. Now, hopefully that does make sense. If you've got any questions on this exam question, do let me know in the comments, but otherwise I will catch you in my next video.